Shipbuilder. As part of government project during World War II, United States planned continuous block construction of oil-welded cargo vessels, DWT-1100 Liberty ship. The construction was started with outbreak of the Pacific War from 1942. 2,708 Liberty ships were constructed from 1939 to 1945. 1,031 damage or accident due to the brittle fracture were reported by April 1, 1946. Mo- More than 200 Liberty ships were sunk or damaged beyond all hope of repair. Schenectady is the one of those which broke into with a large sound when it was moored around. For ductile materials, this a critical combination of stress and crack, length leading unstable crack growth and catastrophic failure. Ductile failure are associated with a large amount of plastic deformation as a result of construct a ductile failure. Brittle fracture usually occurs without any noticeable deformation. High yield strength that allows storage, high elastic energy level, low temperature that cause a ductile to brittle transition in BBC metals, large grain size that build up stress from a dislocation, line ups high straits rates that do not allow time for stress redistribution, course, carbides, or other inclusions that are themselves susceptible to cracking the notches that create constraint at the crack tip. Thick section and the cost plane trait loading. Possible materials, metals. A metals is a materials that when freshly prepared, polished, or fractured show lustrous appearance and conduct electricity heat relatively well. Ceramic and glasses. Ceramics and glasses are inorganic non-metallic materials consisting of metallic and non-metallic element banded, primarily with the ionic and covalent band. Polymer. A polymer is any of a class of natural and synthetic substances composed a large of molecular called macromolecules, which is multiples in simpler chemical units called monomer. To case study, although most Liberty shippers sunk by means of war, significant number of them failed with a sudden fracture that raised question. To discuss the reason of this failure, the representative fates of two different ships will be discussed. Uh, Number one is the John P. Gaines. The John P. Gaines was assembled at the Oregon Shipbuilding Corporation in Portland in July 1943 on its way from Dutch Harbor in Aleutian Island. Less than 6 months after the completion of vessel's fracture, as the temperature hovered around 0 degrees Celsius. The large swell washed over the port bow. The exact fracture origin should not be determined. However, it is assumed that as it 52% of all serious fracture are Liberty ship. Na number 2, the Schenectady. Other than the John P. Gaines, the T2 tanker Schenectady failed after being docked in the Portland, or only a few days after completing trials against air and water temperature were called. However, the ship was uploaded and calm water. The fracture extended throughout the deck, the side of the hull, and the longitude backheads, and bottom grinders, only on the bottom plate. A material selection. Air fracture mechanics, which have only been developed after the occurrence of serious and explainable brittle fracture, allow us to quantify the relationship between materials properties, stress level, and presence of crack product producing flow and crack propagating mechanism. The strength of material is a function of forces between atoms. However, the actual material strength is usually at least 10 to 1,000 times below the theoretical value according to Griffin, who predominantly studied amorphous and ceramic materials. This between theoretical and observed fracture strength can be explained by the presence of very small microscopic flow. In figure 2 is the geometry of surface and internal cracks. Si- This, therefore, this flow and crack are sometimes called stress risers. The ratio of maximal stress divided by the nominal applied tensile stress is called the concentration factor. Concentration is deemed as one of the major factors influencing fracture resistance and materials and complex structure. Impact fracture testing. For this reason, straight sheets such as tension or torsion tests as a room temperature also are not sufficient in investigate the mechanical properties of materials. The discovery of this connection result in the development of additional testing techniques such as Charpy impact. Ito yung Charpy impact yung nasa figure 3, please. Explanation of failure. Knowing the factor mechanics, the failure of the John Higgins can be created by brittle fracture of three main reasons. Many studies indicate that steel quality was a primary factor to contribute by the brittle fracture in the structure. Due to the general state steel star shortage of that time, high quality steel was barely available during World War II. Consequently, the milled steel utilized for the Liberty ship are not yet comply the modern impact absorption standard. The Senectative also failed at a brittle manner and gained the poor steel quality, which then brittle behavior could called condition is one of the reasons for the failure. Some reference also quote hydrogen embrittlement due to poor welding and other reason of the failure. Hydrogen embrittlement is the mostly caused by electrocold welding is wet a jump condition throughout from the author case knowledge. The steel utilized for the Liberty ship can be known as the acceptable for repeated ship. However, the propagating crack and a repeated construction will be stopped at the latest once is arrived to join between two plates since these two plates are laying over the another. A conclusion and future prospect. Today, more than 60 years later, it's hard to give a suggestion. It's apparent that a steel quality that had a higher fracture toughness, allow temperature, should have a prevented many ship from a failing. It's also obvious that more experience and better education welders should have a produced weld without a least with a fewer and smaller flow. Today is a commonly understood that rectangular corners have to avoid it in order to prevent stress concentration. However, considering the constraint of the time, considering that fact a large cargo ship were need quickly sufficient, still not being able and qualified labor being short, there are not many improvement that should have been suggested at the time. Obviously, the relationship of stress and strain was already known as 1940s, and that designers should have know that rectangular corners have need to be avoided. However, the design change made one spiral of various failures become up become apparent. Such a crack arrest of the deck need to be acknowledged. Further, mobile non-destructive radiography equipment to monitor weld quality was not available at that time. So quality control as we know today was not possible 6 years ago, 60 years ago. We need to acknowledge the fact that the emergency Liberty Shipbuilding program was project as this has not been seen before after the unique still today in producting speed. In the latter scope of the program vessels only spent 5 days in dry dock, and its volume never before or after have so many ships of the same design been built. Today, ship and the like are designed to yield before fracture. The acknowledged behind this approach, however, was only developed in 1960. Without a doubt, without without a doubt, it can be claimed that the failure of the Liberty ship caused significant progress of the static fracture mechanics. This highlighted an influence or temperature or on material toughness and hence to specify toughness requirement for weld shift.